We have a great session today. We're going to present you with challenge number 5, which is the open challenge. We have Vera with us. We also have colleagues from EDITO, the European Digital Ocean platform. Okay, I think we can start. I'm going to pass to my colleague Michele. Michele, hello. If you can walk us through the house rules. Thank you.
Yes, absolutely. Thanks so much, Angeliki. Welcome, everyone. Yes, before we start, let's go through the house rules. Exactly as happened last time, this webinar is being recorded. We will put it on YouTube, and you can find it under the Event Tornado Live Sessions tab. So we already have the video from the last session there if you want to watch it. Questions, you can ask them using the Q&A button function of Zoom, and we will answer them after each one of the presentation of the speakers, meaning that after the Challenge 5 presentation from Julia, after that we will have a moment when you can ask her your question, and same for the EDITO platform for Mathis and Felix. After the presentation, you can send your question. You are free to also write them on beforehand if you want, but we will answer them after the presentations. Everything, any question that we cannot answer during this webinar, you know where to find us. We have created a lot of channels on Discord. You can write them on the general channel. You can write us a direct message. You can use the dedicated channels for each one of the challenges. So you know where to find us if we cannot answer all of the questions. Now, the agenda for today. After these house rules, we will have Vera from Seascape, Belgium. She will talk about the challenge number 5, which is the wildcard, hack the ocean with EDITO, which is, of course, the open challenge. Then we will have Felix and Mathis from talking us about the EDITO platform. And then in the end, we will provide you also with the next steps, which are basically what are the next planned live sessions. So without further ado, I will we will watch together the video about challenge 5, the wildcard.
Hello, my name is Vera. I'm the lead manager for business and strategy at Seascape, Belgium, where I work in applying digital innovation to ocean knowledge. So if you're watching this video, that means that you're probably thinking about joining Open Sea Lab 2025. I imagine that you're passionate about the ocean. You want to be on the side of those who search for solutions to keep it healthy, to keep it alive. And maybe you've already browsed through the challenges of this hackathon edition, but you feel that there's so much more that you could do. You could maybe work with something else beyond just EMODnet data. So if that's the case, the Open Sea Lab wildcard, that's challenge 5, which I will be mentoring together with other colleagues, might be exactly what you're looking for. And I will tell you why, but let me first tell you about EDITO, because it is central to this challenge. EDITO is the backbone infrastructure of the European Digital Twin Ocean. It's still at a pre-operational stage, but its core elements are already there. So it has the best ocean data lake that you will find in the world, combining data from Copernicus Marine Service and EMODnet. It has next-generation ocean models that combine artificial intelligence with high-performance computing, and it has a fantastic co-working environment that you can use to build applications and what-if scenarios. So if you get a kick of combining satellite data with in situ data, or if you're craving for computing power to run models or to make ocean predictions, then I'm pretty sure that you will love harnessing the EDITO platform to respond to an ocean challenge of your choice. And you do get to decide what challenge hits home to you. So have a read at challenge 5, let your imagination run free, and team up with the European Digital Twin of the Ocean to shape the future that you wish to see for the ocean. See you at Open Sea Lab 2025.
All right, Julia, we've seen you on video, and now we can see you here. Welcome. The floor is yours.
Thank you very much, Michele. I have a presentation. All right, so good afternoon, everyone. Again, my name is Julia Vera. I work for Seascape Belgium, and I'm here today to introduce you to Challenge 5 of the OpenSea Lab Hackathon. First of all, let me say that I'm really thrilled to share this edition of OpenSea Lab with you. And I'm really excited, I would say, for two main reasons. The first one, because as you've seen in the video, I'll be acting as the lead mentor for Challenge 5, which is the wildcard. And I really love the idea of the wildcard because it gives you complete freedom to apply your creativity to an ocean challenge that is really important and relevant and dear to you, which I think it's really important. But also because this year the wildcard is connected to the use of the EDITO platform, which in my opinion it's a really exciting development for anyone who's seeking to harness marine data to find creative solutions to ocean challenges. So over the next 10 minutes or so, I would like to give you a bit of context precisely about EDITO. What is EDITO? How is it related to the European Digital Twin Ocean? What problems does it solve? But also, as it is most relevant to you, also what assets does it bring to you that you can leverage to build something that is great, that is unique at OpenSea Lab. These are more or less the contents that I will cover in today, because my colleagues Felix and Mathis are also with us. They've already been using EDITO to build applications that address ocean challenges for quite a while through the EDITO Model Lab project. So they are the ones that will actually be showing you the EDITO platform really hands-on. So my plan is to give you a short introduction, and then I will leave it with them to go for a deeper dive into the platform itself, into EDITO. So what is EDITO? Basically, as you can see in the slide, EDITO is the backbone infrastructure of the European Digital Twin Ocean. You might recall that about, I think it was 3 years ago, President von der Leyen announced that Europe would build a European digital twin of the ocean to make ocean information available to all. And in my opinion, her announcement was very timely. It was a very good call. And I'd like to start by explaining you why I think it was a very good call. And I'm not really sure how familiar you are with digital twins, but digital twins are very powerful tools that we can use to predict future ocean scenarios and to inform better decision making. And they are great tools because we can use them to respond to what if questions, right? So we can use them not just to know what's happening somewhere in the ocean at a specific time or on a specific event, or what might happen next month, let's say, which in a way, this is something that we can already do with our digital twins, but we can actually use digital twins to set up scenarios around possible alternatives for action that are available to us to address a specific problem, and also to assess the results that our proposed actions might deliver before we actually implement them. And that's, I think, that's exactly the beauty of digital twins, and that is also why we say that digital twins are decision-making tools. So maybe to give you an example, say that we have a problem with plastics floating around the island of Madeira. A digital twin application might help us to, let's say, to visualize where the plastic is coming from, what is the most likely source of plastic based on available data and available models. But in addition to that, let's say that we decide we want to take action to reduce the presence of plastics around Madeira, then a digital twin application can also help us to understand where should we put our efforts to really optimize the outcome of our actions, right? So what if we decide to implement actions to reduce the emission of plastics from coastal areas in Southern Europe, right? Say the plastics are arriving to Madeira from the north of Spain, from the Canary Islands. So what impact will our actions have in terms of tons of plastic that we can remove from the waters of Madeira if we decide to act on those areas, right? And how does the impact of our actions might compare to actions that we might take to reduce plastics that are coming from rivers instead of coastal areas? So basically, what is more efficient in terms of the outcome that we're looking for, in this case, in terms of plastic that we want to remove from Madeira's waters. These are the type of questions that we can respond using digital twins. And as I said before, President von der Leyen's announcement was, I think, very timely, basically because in Europe we have all the right ingredients that are needed to harness the power of digital twins of the ocean. We have a very strong ocean observing system that gathers millions of satellite and in situ ocean observations. We have very good operational marine data services like Copernicus Marine, like EMODnet, which make most of the data that is derived from those observations publicly available to all, to advance research, to advance innovation. But we also have, and this is really important, we also have a thriving network of researchers, environmental modelers, data scientists, software developers that work to transform all of this data into knowledge. But, and there's always a but, yes, at the time of von der Leyen's announcement, Europe was probably still missing one key ingredient that is really needed to enable and to speed up the development of digital twins of the ocean. And that's exactly an infrastructure that could connect all of these elements together, bring them into a single digital framework so that the research and innovation community, people like you, together with societal actors, can build what-if scenarios and applications that respond to specific ocean challenges. And that is exactly what EDITO is. That's exactly the infrastructure that EDITO is bringing to the community and that we're bringing to you at the Open Sea Lab. And I have to say that it's very exciting. And it's very exciting because, first of all, as a key component of EDITO, we are building what's probably the best ocean data lake in the world. So far, we've been able to bring data from Copernicus Marine Service and from EMODnet into a single data lake so that people like you do not have to worry about processing data coming from different sources. You can basically just get straight to work without really having to waste time processing data. Secondly, we've also made it possible for anyone with a normal computer, really with a small computer, to log into EDITO to run big data analysis, to work with artificial intelligence, without having to worry about having enough computing resources, right? So when you're using EDITO, you don't worry about computing. You also don't need to download data or to worry about hosting costs. So basically, you can already do great things from your laptop. And last but not least, I'd say we've built a co-working environment that will enable you to build applications, what-if scenarios, but it also enables users to share the results of their work. So also enabling collaboration across research communities. And that's important because it means that when you log into EDITO, you don't have to start from the scratch, because you can actually build on top of models, on top of applications that have been built by others, and you can basically bank on their previous work and their previous experience. So basically, in short, I think we can say that EDITO is a platform that goes well beyond traditional marine data portals. It really offers a wealth of tools and community resources that you can leverage to build digital twins. And the great thing is that even though the construction of EDITO, the infrastructure, the platform, started, I think it was roughly 2 years ago, and as we've mentioned, it is still in beta testing mode. But during this time, besides developing the platform, the infrastructure, we've also teamed up with a number of projects and initiatives that are already using EDITO to bring solutions to ocean challenges, to support Mission Ocean and Waters around its objectives of reducing marine plastic pollution, addressing coastal hazards, and really supporting, stopping pollution and supporting a blue economy. So the exciting thing is that many of the resources that these projects have generated are already openly available in the platform, and are there completely ready for you to also harness them and for you to use them. So I would say that if you're thinking about joining Open Sea Lab, and if you have a great idea to solve solve a problem that is relevant to you, but you're maybe still struggling to bring your idea to life, maybe because you need to combine different data from satellite and in situ observations, which is always very challenging, right, and time consuming. Or if you need lots of computing to run a model, or you need to rely on available models to build the applications that you have in mind, but you don't really know where to find them, then I would say that EDITO is exactly what you're looking for. And especially for OpenSealab, as I've already mentioned, it will give you fast access to data, it will give you fast processing, and it will give you a really nice library of tools and models and applications. So really a treasure trove of resources that can help you to bring your specific your solutions to life. Also during the hackathon, you will have technical experts that have been involved in EDITO supporting you. So I'm not really sure what else can I say other than really go for it. Yeah, maybe to wrap up, as I mentioned before, Felix and Mathis will introduce you to the platform, what's available at the moment. But I think we will be sharing these presentations with all of you. So I wanted to also leave you here with a few links to training tutorials, to applications that are already available in EDITO and that can provide you with some inspiration. I highlighted 3 here, the Marine Plastic Tracker, the Nature-Based Solutions application, or the MPAs for biodiversity application, but there are many, many more. We have at least 4 what-if scenarios and 5 focus applications that are already running on EDITO that have been produced by our colleagues from EDITO Model Lab, as well as other projects. I'm leaving you here with some direct links to their training tutorials in case you wish to explore them and to tap into them to build your solution during OpenSealab. And I think that's probably all from me. I hope I didn't go through all the information too fast, but I'm also available to take any questions that you might have, either now or after the presentation of Felix and Mathis. Up to you, Michele, how you wish to run it. But thank you very much for your attention, and I really look forward to seeing you and to meeting you at OpenSealab.
Thank you so much, Julia. This was great. Questions? Do you guys have any questions for Julia?
I would just like to say that this is the perfect opportunity. It's we also went through this in the previous session. It's a really wonderful way to connect to mentors and coaches. And as we're trying to also stress, mentors and coaches are part of your team. You should consider them really part of your team. They are here to help. So this is a great opportunity. If you would like to interact live, you can take this opportunity. But again, Julia, you gave a really great presentation. It was all inclusive. So let's see what we get.
We got a compliment. Very useful. Thank you, Julia.
Very glad to hear. Thanks.
Yeah.
Let me send a link. I will send you a link to EDITO, so you can take a look at further information as well. From the link I will send you, we'll see that it leads to EDITO Infra, which is the data lake part, but please also take a look at EDITO Model Lab. You'll find the link on the website. This is what our colleagues from Mercator Ocean and Deltares are going to walk us through in the next part of this session. Okay.
Okay, we have a question about mentorship and coaching classes.
Well, they're not exactly classes. They are, yes, well, they are warm-up sessions that are mainly meant to further explain the challenges and the current status quo, and to also introduce you to the tools that you will be using. We will also share a resource pack with you next week. But you can take a look again at the profiles of our mentors and coaches and what they're there to support. So mentors, in a nutshell, are there to interact with you on the subject matter of your idea. So there we will have experts on many different themes, from biodiversity and oceanology to physics, chemistry, bathymetry, etc. And then coaches are there to support you, mainly in your data search. So when you're looking for data, whether it is on Copernicus Marine, on EMODnet, or on EDITO, coaches are the ones that will be able to support you in this. So I don't know if Sutapa, if this clarifies generally. And about not having joined any team, we do have another session tomorrow, which is absolutely dedicated to this theme of helping you get into teams, because it's the most important part at this point. If you would like to join us again tomorrow for this, and you will have an opportunity to take a look at all the teams that are currently formed and see where you can fit in.
I will get in touch with you, Sutapa, to ask you if maybe you want to basically share some your skills and background tomorrow. It's going to be a very informal live session. So if you want, if you're up to it, you can absolutely. Okay. Yeah, I think it's we can go to the next part of the live session. So welcome on stage, Mathis Bertin from Mercator Ocean International and Felix Dols from Deltares, which they talk with us about the EDITO platform. The floor is yours, guys.
Hello, thank you, Michele. I'm going to start to share my screen. So Julia gave a very good introduction to EDITO and what's its purpose. So you are probably wondering how to utilize it. So that's what we are going to present with Felix. So we are. I'm going to start with a different showcase of what you can find on EDITO, and then Felix will show us an application that he developed on EDITO. So let's dive directly into it. When you go to dive.edito.eu, this is a landing page that you are going to find. So from here you can access everything that you will need, and I will show you how. So first of all, you can find some what if applications that are exposed and developed in EDITO. As Julia said, you can find, for example, marine plastic tracker or NEI forecast model that are running on EDITO. I'll let you play with that. It's quite intuitive and interactive to use. So then the very important part of the trainings and tutorials, most of them have been written by the EDITO Model Lab team, who Felix belongs to. You will find some thematic tutorials on how to do things on EDITO with some example. But Felix is going to talk about it later. One important part of our platform is obviously the documentation. If you want to take part in the EDITO project and contribute to the digital twin, this is a very good starting point because it will guide you through everything that you need to know to use EDITO to its use EDITO as a whole. So the documentation is sorted by what kind of user you might be on the platform. If you want to explore, create, or contribute, as well as some use cases that we detailed here, because we find that a lot of people who need those kind of use cases for developing an EDITO. We got questions that were coming back a lot, so we decided to write documentation about it. So yeah, very important page. Then if you click on integrate data, you will land on the viewer, which is interfacing directly with our data lake. So this is where you can search for data as well as viewing them. So you have a menu on the left. You can search, for example, for EMODnet product. I don't know, marine geology, for example. Well, I'll let you explore what kind of data there is on the platform. But as you can see, you can access it and display it, as well as having access to a lot of metadata about what is displayed. So one thing to note about the data lake, it's that it's implementing the Stack API, which is a standard, which means spatial temporal asset catalog. It's very convenient to sort geospatial data, or at least metadata, and referencing them in an organized manner using JSON format. Finally, this data lake is also interfacing with the data lab, which is kind of the main focus of EDITO, because this is where you are going to be able to run some computation near the data. So from the data lab, you will be able to launch services, for example, a Jupyter notebook, to and benefit from the computing power of EDITO underlying, as well as being near the data. So yeah, I think that's it. Now I'm going to let Felix introduce us a showcase of an application that he developed in EDITO. So Felix, the floor is yours.
Thank you, Mathis. I will unmute myself and share my screen. Yes, I think I'm sharing now. Let me get this out of the screen. Yeah, so from the EDITO Model Lab perspective, we're actually beta users. So we are the first to use the platform that Mathis just introduced us to, but also to contribute to it. And that benefits both the development, but also benefits us as being the first to explore how it works, and also give feedback on how we think it should work. First, to introduce again, our goal is to make ocean knowledge accessible, and it's both data, so a technology like Stack to make it as findable and useful as possible, but also ocean knowledge is not only static data, it's also to be able to work with the data, so to compute. I will stay with that point. So we are publishing our tools, for example, from our institute, we're publishing our tools open source so that other people can work with it. And EDITO allows to compute on the platform, so you don't need to bring your own computational core. It is giving you access to high performance computing and cloud computing. So we're a group of early users or contributors, and we integrated some services and processes. This is how we call our tools and our software that we published. And they all have a way of adding or simulating a marine phenomena of different kinds. And the applications, they demonstrate how these processes and services that are all modular, so they can be combined into a new workflow, how they work and how they could be used. But it's also as an inspiration to use it in any different way. So therefore, this is already an encouragement in the hackathon to create a vision on how to use different services and processes for solving your problem. The applications are open source and parts of it are open code. So you can also adapt the code to do something different or to run an on-demand simulation when, for example, you change the area where you want to calculate something. This allows technical users to reproduce and even to evolve some of these processes and services. And it's allowing non-technical users to use the generated data. This was also showed by Julia, but there's 3 levels that we see you could interact with the platform with. So you can explore the data in a viewer like also Mathis has shown. You can contribute. So when there's research has been done, it's also motivated to contribute your data, but also contribute with new services. And if you really want to create and publish a new service, then that's the most advanced level of interaction. And we expect you to start with exploring. But if there's any interesting data generated during the hackathon, then that would be interesting if that's also uploaded. We'll show you later how that could be done. First, we will show some services and processes on the platform. So this was already shown, but if you search in the trainings and tutorials page on applications, there are some applications that can be found. This is a combination of the what-if scenarios and the focus applications that Julia talked about earlier. And they all have manuals where we explain the scientific background. I hope nobody has epilepsy because it's all moving. But I showed this because there's a lot of information also about the scientific background, giving references to research that has been done. There are some screenshots that help you also to reproduce what is done in this application, and sometimes even videos. And it's all step by step. So this helps users to reproduce what has been done in an application and refers to the services and processes that were used to do this scientific work on the EDITO platform. So we'll focus on one, and it's about habitat suitability that we do in marine protected areas as a biodiversity indicator. And here I recorded some interaction because I didn't dare the live session like Mathis. But there's different ways of finding your information. And so here, for example, there are some ocean models and documentation on that on the trainings and tutorial page. We're now looking for focus applications, and we open the manual or the tutorial on habitat suitability model. And if we scroll through, it's a step-by-step and also explanatory page on what kind of steps were taken to get there. And you don't have to understand everything now. But these kinds of links can be found on the platform. And if you cannot, you can always reach out. What I want to show now is that there's also a workflow that step-by-step explains the different services and processes used. And we will go through them. So this is one example of an application using multiple services and processes that are available on EDITO platform with the goal to model habitat suitability. Here, I want to explain what kind of service and processes are used. And so we have a model builder to set up a model. This can be done anywhere in the world. When you, as a user, define the area where you want to model. We also set up ecological impact assessment with a tool, a YAML file. But with this model builder, we set up a simulation with Delft3D. This is one of the ocean models, and there's a couple. There's already 4 different models available that all do simulations of physical and biogeochemical processes of water or in the water. And with Delft3D, we create spatial output, combining that with the UK Impact YAML that we created with the other surface. We can do ecological impact assessment. So we can use biological knowledge to say something about how suitable an area is for a certain habitat species. So for a core species for ecological system. And we've done this for a marine protected area in the Wadden Sea, but it can be done anywhere in the world. And then we also have a post-processing surface where you can visualize your results, and you can compare it to validation data. So now we go through the first step, and I hope this would run automatically, but I have to click. And so in this tutorial, we click on the first step, so the model builder tool. And so it finds it by searching it directly. Here there's some configuration that you can do. For example, credentials to a climate data store, which we access outside of the EDITO data lake. That's not integrated yet, but the accessing of the data is automated in that way. If there's any questions about this, please reach out to me later. And we open this service now. So it's not running on your computer. It's running on the infrastructure of EDITO. And this service is, I'll take some water. This service is interactive. So Jupyter Notebook environment is open. This is some open source code. And we will talk you through step by step. I hope this doesn't bore you. It does go into a little bit, but I hope it also shows in how we envision we could collaborate. And so here a user can define which area he wants to model and also which period in time. And then step by step, we're going to get all the files to make a hydrodynamic simulation in that area. The specific area now is a coastline or part of the coastline of Vietnam. Here automatically a boundary, open ocean boundary is defined. A grid is refined using the bathymetry, and this data is loaded as we go. And I didn't pause the video more than maybe 10 seconds here and there. So in a couple of minutes, we're going to set up a new model. And we cut off all the cells which are on land. We don't want to do any calculation there. And we visualize here the bathymetry, so the depth of the domain that we are interested in. Here we now we're downloading tidal components, and still this script uses some data outside of the data lake. So as we're expanding the data lake, hopefully we can use most of that through EDITO, but now also open data outside of EDITO is used. And so step by step, now we're for the period and for the location we were interested in, we're getting the data that forces our model. And so we set up a grid, but we want to know what was the ocean doing just outside of this grid at our time of interest. And here I forwarded a little bit, so it downloaded all of this data. And we can also visualize it, so you can learn, okay, what kind of data, what kind of model am I actually setting up, and simply seeing what the data is at the boundaries.
Sorry to interrupt you, Felix. They're asking if you can zoom in on your browser to see the code. I don't know if that's possible.
Yeah, so for the sake of keeping the overview, it's hard. I think if we find a way to upload this video, I will pause it. Then it is also maybe in higher definition, so it's easier for people to look at it at home. So let's put an effort into uploading these videos in a file share.
Yes,
good
makes
solution?
sense.
Okay.
Very great solution. Thank you, Felix.
And so the idea is maybe not to understand all of it. This code you can find, or one of your teammates can find on the EDITO platform, among with many other services. Now we continued in downloading climate data, so the forcing from the atmosphere for our model, and also this we want to visualize. So with this prepared code, we see the data that forces, or an average of the data that forces our model. We set up some observation stations at random points in our domain, but a user could choose to do a different thing. Here we see what kind of files we have created that will help to start the model. And to be able to run it on the EDITO platform, we added an extra step, which is a Docker container that is created. And all of this is now in your automatically in your personal storage on your EDITO platform. And so this is not published yet, but all the files to run a model are now ready in your S3 bucket, as we call it. So I'm going to skip this step, but I will say what it does. So here, oh, it's repeating the same step. Sorry about that. This was the next step. So we also need to, for the ecological impact assessment, we need to load some biological rules, which tell us how a habitat species responds to how the ocean is doing. So these response curves, there's a repository where you can make them yourself, and we want to optimize that. That's still in progress. But here we uploaded a file where you can run the eco-impact with. Also this, you don't have to understand all of it, but basically it tells something about the relationship between, in this case, a seagrass and, for example, sea temperature. So when we have calculated temperature, we can say something about how well the seagrass is doing. So here we go through that file, and we advise to download it and to upload it in your S3 bucket. And we're going to use it later in when we start the eco-impact process. And so we have created a model input for our simulation. And now let's start a process which is called Del3D to run a Docker, so to do a computation on the platform. And we can choose ourselves how much, up to a certain amount, how much resources you want to use. And you can do this by sliders, but in every process, there's also a way to create your files yourself. And so now in the lines in the bottom, a container is created. So a software package is contained in this Docker container and is now running on the platform. So no installations have been done as a user, and you've done a simulation on the platform. It's successful because it was only 2 days and a small model, but it created spatial data in your My Files. And later on, you will see what it is. We're only going to visualize it after also doing a next process with the data. And so we've created spatial data for this area in Vietnam, and we want to do this habitat suitability model. We use the tool eco-impact for it. Again, we can choose our resources, and we can choose this YAML file that defines the ecological knowledge rules. And this is the location in my files or in my S3 bucket that we defined. You can also copy that. So it's the example that we copied. And now we're running a second process called deco impact. Again, no installations need to be done. And this code could be found, but you don't have to do anything about it because it runs, in this case, as a black box on the EDITO platform. And it has created outputs for habitat suitability. Okay, now we have done all these things, super interesting, but actually we also want to see what we have calculated now. So in the next video, this is a post-processing service to see your results after doing these data manipulations with the two processes. So it's a service, and again, we're opening a Jupyter notebook where the user sees the code that actually is used, and it's more interactive, less of a black box. So here in this post-processing service, and we're running it all at once, and we're following what it does. So we have to import some packages, and we get some information about the data that was in our end product. And here we see suitability maps relative to one parameter, and then a total suitability map. And this is for that area in this hub, in this marine protected area in the Wadden Sea. We can compare with validation data. The comparison is not so interesting yet because we only ran for 2 days. And in these 2 days, it was not a suitable area for the seagrass. So we were unlucky, but normally you'd run for a whole year, but that takes a little bit too long for such a demonstration. We see that the data is saved here in your account, and you can transfer it back to your to the EDITO platform. So this is done. Before ending, I also want to say something about using the data on EDITO, and I thought Mathis would introduce this, but this is an overview of the data lake, and most important is that there's now already a couple of external data lakes which are integrated into the EDITO data lake. So most importantly, EMODnet with different data catalogs and CMEMS with different data catalogs. But also users can contribute to this data lake and can browse through different catalogs through location or a different kind of parameter that you want to know. You can browse in an efficient way through this enormous amount of data. You can do this as a person, but also machine-to-machine interaction is possible. And there's some documentation also about how to interact with this data, so how to use it. That's a bit more intuitive because there's also a viewer for it, but also how to upload. So we call this interacting with the data API, and APIs are for automated interaction if you want to create a service. And this might be beyond what you're able to do in the hackathon, but it could be interesting to already know how you would integrate your idea of your application on the EDITO platform. And I will skip through it, but in this documentation page, there's a lot about how to interact by getting or providing data to the data lake. So I'll click through to the next one because there's one good example of our colleagues from Mercator Ocean that are working on GlowNet that have contributed their data sets to the data lake. So apart from the CMEMS and EMODnet data sets, also other people are contributing now. And so here they say, okay, we've published some data on the data lake. We're now in the viewer again, and under GlowNet, indeed, we see some data sets that they have published. We can see the data visualized here in the viewer, and we can also download it if we're interested in it. I want to end with some comments and encouragements before we open the floor for questions. It's in beta phase, so it requires some perseverance to work with it. It's not yet the digital twin with a viewer where you can do real life or real-time manipulations. We're still building towards that. But you help us a lot with every attempt in working with EDITO, and every problem you run into is valuable feedback for us and will help us to create a more useful environment along our way. And so we encourage also during the hackathon, but also before, to explore the services, processes, and data that are on the platform. And we showed now one example of an application, but there are already more. Questions are very welcome if you want to reach Mathis and his team. I think also we should share these links, Michele,
in the chat.
In the chat. Yeah, that could be nice to copy. I will do that later. This is to reach Mathis's team, and the other email address is to reach my team. We value in teams that they are eager to test all the available EDITO services, processes, and data sets. So curiosity is valued. Any vision in how your idea can contribute to a service, to a process, or to a data set. And so even if you're not able to implement, it's good to have a vision on how to do it. And any kind of feedback is appreciated. And in the end, we would love for EDITO to also contribute to you harnessing the power of open data.
Thank you. Thank you very much, Felix. Thank you very much, Mathis. Great presentations from everyone. I just want to take this opportunity before we go to the final Q&A. Felix just mentioned we are in beta phase still. We mentioned this yesterday as well. It is the main reason we can unfortunately not allow all of you to directly connect to the platform. You will have to provide us with 1 or 2 emails maximum from your team. Please provide those. If you already have a team, please already send us your email. If your team has 3 people and above, then we can provide you with access. It will be very valuable to you to get to know the platform beforehand. That is also a very good reason to go ahead and form a team, put your idea on Event Tornado, be very proactive about finding team members. Everyone has put their skills there. Reach out to everyone. This really is a unique opportunity. This is the first time we're doing such an in-depth presentation of EDITO to users that are not in our projects or are directly working with us on this. So we're very, very happy to open this, to open the platform up further. And again, as Felix mentioned, as again we said yesterday, it is very important for us indeed that you give us your feedback. This is a main reason we wanted to include the EDITO platform in this edition of this hackathon, because your feedback and your comments have been truly priceless in the previous editions in us optimizing our services and our data products. So with this, we're going to go to a Q&A. We only have very few minutes left, 4. So please let us know what it is that we can answer now that we have our experts present here. So Julia, Felix and Mathis are available for the next few minutes still.
While we wait for some questions, let me share my screen for a second. So Mathis kindly shared the emails mentioned for the support. That is one way. We have set up also for you the coaches channel here. So basically in the coaches channel, you have all the list of the coaches, especially for EDITO in this case, but then for EMODnet and also for Copernicus Marine Service. So feel free to tag Mathis and Felix here, or Loring or Connor when he will be available. So this is another place where you can of course receive support from them. See that we have. Okay.
Okay, we do have a question from Anne.
Mm-hmm.
She's asking about the available data formats and their availability to be downloaded for academic purposes. We will leave this to Felix and Mathis.
Well, I can answer for the Copernicus marine data that are available in the ZAR format, which is more convenient for cloud computing. For EMODnet data, I'm not sure. So Felix maybe has the answer.
Yeah, also NetCDF files. So this is in the modeling practice already for a long time, the standard, and also these kinds of formats can be uploaded or are available now. And I think that would be most of the data lake. I don't know of any other formats available.
I think also, I don't know if this is something we can mention, and maybe Julia can also follow up on that. But the great thing about, of course, you can download both Copernicus Marine and EMODnet data directly from our services. You will find all this information in the resource pack. But the great thing about EDITO is that you don't actually need to download the data. You can directly work on the platform. Julia, anything further on that?
No, exactly. I was just going to say that many of the EMODnet data is also available in SAR formats. That was one of the questions. But then, as Angelique is saying, I mean, the beauty of EMODnet, Copernicus Marine, is that they are open data services. So, I mean, EMODnet, yes, everything is available for download. But as Angelique was pointing out, the beauty of EDITO is that you don't have to download the data to really process it and to work with it. And when you're working with big data, like the data that Copernicus Marine is offering, EMODnet is in situ data, so it's very different, right? But basically, downloading might require having a huge storage on your computer, and that can be challenging. So with EDITO, you avoid all of that. That's one of the pluses.
Thank you. Well, everyone, it is 4 o'clock. It is time for us to finish this session, but we are available ongoingly to answer your questions. Send them to us via email. You can send them to us via the support channel. You can already start contacting some of your coaches and mentors directly. It's great if you take this opportunity. We are all here to support you. Thank you so much for joining us again for this session today on Challenge 5 and EDITO. Thank you to all of our speakers as well. And we look forward to seeing you again tomorrow, the same time, where we're going to further discuss how you can enter a team and then join the hackathon and offer some great solutions and hopefully also win some really nice prizes. So thank you very much. We are going to be uploading this video very, very soon as a resource, so you can rewatch it or share it also with your team members. Thank you.
Thank you. Bye-bye.
Bye.